And we're live. Welcome back to another Corona Geek here where we talk all about mobile app development using Corona SDK. I'm your host, Charles McKeever, and today we're going to talk about rag dolls. We're going to talk about physics, talk about joints, talk about physics bodies. We got a lot of stuff to talk about. Joining us today is Ed Marina from roaminggamer.com. Hey, Ed. He's got his mute on.
Had myself muted.
Also joining us is Greg Pugh from GP Animations. He's joining us from the underside of something. Can you guess what it is? If you can, good for you.
No bonuses for guessing.
No bonus. Bling, bling. There you go. That's all you get.
He's pretending to be.
Earlier, we were trying to figure out, yeah, there we go. We were trying to figure out all the attachments at the bottom. DVI, USB.
Oh, now you're giving it away.
Oh, I'm not giving it away. Well, okay. Were they supposed to guess it on their own?
Yeah, well, they'll guess it.
But where is it? Where are those things located? I thought it was under his desk. You said it was something else. Yeah. Anyway. So Greg's here with us. So Greg's been away for a while, and he's back, and that's great. Good to have you here, Greg. Okay, so let's do a few announcements before we get into today's material. Corona Geek 145 is up for your viewing pleasure. And I did notice that this time a lot of people watched the clips. Almost as many people watched the clips as watched the show, which I thought was interesting. Generally we get a kind of a mix. Some people watch the show, some people just watch the clips. But this time, we talked about creating library extensions using JSON to load and save data, and also persisting data across different sessions, which apparently struck a chord. Struck a nerve is a whole different thing. Struck a chord with people because they watched those in long form and short form. So if you want to do the same, you can go over to youtube.com/coronageek. You can find 145 there, and also watch all the rest of them too. There's 144 other shows that you can watch. Some people actually do go back and watch. They start watching from number one, and then they watch all the way through, which I find completely amazing. It's just
it's good.
Yeah, because each show is like an hour long, so that times 145 is a whole lot of watching.
145 hours.
No,
Don't confuse me with your math, Charles.
Yeah, it's sorcery.
We're all here to help you out.
Number sorcery. Okay. Also in June we are playing Alone and 1.1 Target. So we're playing 2 games this month for the chance to win a $50 gift card. So if you like to play endless runner type games, then Alone is going to be a great one for you. It's available on iOS and Android, and we've also featured it in the desktop demos, the upcoming Corona beta of desktop support. Alone has been one of those apps that we have demoed using desktop, so you can find that as well on the YouTube channel. And also, but Alone is a paid app, so if you are wanting to do a free option, you can play 1.1 Target. It's available on iOS and Android as well. And it's more of a one-touch kind of shooter, kind of jumper kind of game. So it gets progressively harder as you go because of the levels. It introduces additional barriers and blockages. But both games are fantastic. So if you get a chance, go over and download one of those, play, and then all you have to do is go over to facebook.com/coronageek and post your high score. So that will enter you for a chance to win a $50 gift card. We'll announce the high score winner at the end of the month, so be sure to play. Also, one other thing I want to tell you about before we get into the content for today is that the Udemy course is still available from Daniel Williams. It's on game development using Corona SDK in 2015, very specific title, with ASO and ads. So if you are planning to actually publish a game, not just create it and put it on your desktop, this is going to be a course for you. So you can get in there and optimize your listing in the store, and also maybe monetize it with some ads. So it's kind of a end-to-end type thing. And he doesn't do one of the things I'd like to see Daniel do is a course on creating your game graphics. He supplies all of those for you though, as part of the course. So you go in, you download the material, you get the graphics, the sounds, the code, everything that you need. I mean, the game's already pretty much ready to go. And then from there, you can take the course and learn how it's all put together. And if you want to, you could probably even reskin it. So that's a great course to take. You can find it on Udemy. We'll put a link in the show notes. And if you use the coupon code CoronaGeek, you get the course for $9, which is insane. It's an absolute steal. I mean, like I said, you're getting the graphics, the sound, the code, how it all is put together, and all that for $9. So go check it out. All right. So Jason, thanks for joining us. You're not in the car today. That's good.
Nope.
I'm concerned for your health and safety in the car because it's summer is upon us, and I don't want you to pass out in the car, and then we're like.
No, don't worry. I'm usually running the AC.
Oh yeah. Oh good.
Burning gas.
Burning gas for an hour. Great. Got it. Well, thanks for joining us today. I appreciate it. If you guys haven't had a chance, go check out jasonschroeder.com. Jason's got a lot of great stuff over there. Libraries for doing things and radial timers and all kind of stuff. I can't even. There's too much to list, but go check it out. Ed, what are you showing on your screen? What is that?
I'm just getting ready for announcements. We're still in that phase of the game here.
We are. Go ahead.
I got a cough.
You got to play golf.
Sorry about that. I got to clear my throat there. Okay, so I had a goal at the beginning of the year. I was supposed to release 26 games this year. I'm way off the mark, but things are starting to warm up. I have currently released 5 games. On Android and on iOS. They're still running through the iOS approval process. It lags tremendously, but they have mostly gone through once, and then I had to make a correction, so I think they'll just fly through again once they get to a reviewer's desktop. So there isn't much to say there, but the AMU, another mashup, is what that stands for. Games were something I mentioned previously. They're a mashup between asteroids and some other mechanic. For example, MULL is lunar lander mechanics for motion, but everything else is like asteroids. FB is like Flappy Bird for motion, and DTTS is don't touch the spikes motion, bouncing off the walls basically, combined with asteroids, because I thought it was kind of a curious thing to try to take and put 2 game mechanics together and see how it would change the experience. And for me personally, I like the lunar lander and the Flappy Bird combo. The DTTS it's a so-so, but I don't really care for it because I can't get very far before I die. And then I got a new game which I had some folks review, Red and Dead 2, which is it's a 2-touch game, and some folks had trouble playing it because it's a little bit different from what you're used to when you see, like, what was the one by Ketchup? It was the Amazing Brick.
Mm-hmm. Yeah.
So that was a touch game where you would touch the screen and the brick would get like a little kick. Sort of a similar concept here, but it doesn't get a kick. It gets, the longer you hold, the bigger the kick is. So you can finesse the brick in a sense, if you want to think of it as a brick. Although I really wasn't starting there. I wanted to play around with different input types. So this is an experiment. Anyway, long story short, things are starting to ramp up. I'm working on a game with somebody in the community. We'll hopefully get that released here in a couple of weeks. It's going to be a rather big game. At least for me, it'll have a number of very interesting features. In fact, I'm hoping, if we get it done in time, to get it maybe encourage people to play it as one of the monthly games on the show.
Oh, that would be cool.
Because it'll be on Android and Google, or Android and Apple, and it has a multiplayer facet.
Oh wow!
Nice.
So,
can you give us any more details? I'm intrigued.
I can't really talk about it because if I tell you too much, it'll totally let the cat out of the bag. Exactly. We don't want a cat, so you got a cat, but okay. You got a cat, right?
Hey, so the icons are very similar. Of course, they're all space shooter kind of icons. Yeah. Are they kind of the same code base but just variations?
Yeah, absolutely. So the way I did this, coded this game up was I went in and I coded up the base game. Let me go back here. which is AmuB. This is the one. It's basically asteroids, but instead of having just bullets, you've got bullets or missiles. You've got multiple barrels to your weapons, so 1, 2, and 3, and you get shields and some other power-ups, basically that you can connect or collect here. So these little icons here are power-ups. So this is what sets you up for understanding the game mechanic. And then what I did was I said, all right, let's take all of this and twist one little part. And so instead of flying around like you would normally with your ship, I changed the input mechanic and I made it act like Flappy Bird or Lunar Lander. And then every other part of the game stayed the same, and I just made minor tweaks to the art so you could tell you were playing a different game. And I guarantee, these are free games, by the way. I guarantee you, if you start off with AmuB, which is the base, and then you play one of the other ones, you're going to say, wow, that completely changes the game. You've got to approach it with a completely different strategy for winning.
So is this sort of an 80? Are you trying to do like an 80-20 sort of thing, or it's just all about the experimenting with the different mechanics?
Well, I just wanted to do this for a long time, and so as far as like mashups, because I thought it was an interesting idea. So this is my little side trip into mashing up mechanics. But I'm going to stop doing it now and start just doing other interesting mechanics and game ideas that I have.
So from a keyword perspective, AMU-LL is not, nobody's going to search for that. So
much. I ran into a problem here where you're not allowed, Google is really clamped down. You are not allowed to use the word flappy or asteroids, or you traipse even a little bit across the line.
Even in your keywords or in your title?
Anywhere. Anywhere except for I put it in the description inside the game, the actual text. So if you play the game, there's a help. You can bring that up. It'll say that this is a mashup of asteroids and Lunar Lander or whatever.
And I think your descriptive text is searchable in Google Play, correct? Unlike iOS.
Oh yeah, the description here on the store.
Yeah.
Yeah, I believe it's all. What do you call it? Crawled by the.
Well, that's
Google.
nice. I mean, that at least reduces some of the,
That's why they jump on you, though, because they don't want spam. That's what they basically call it. They call it keyword spamming.
I think it's a
really nasty letters from Google when I initially said, "Hey, this is a mashup experiment of these mechanics." And I was very clear. I wasn't saying I'm making asteroids or Lunar Lander or Flappy Bird. I'm saying this is an experiment, and this is what I'm doing. But they don't read it. It's just a computer. It is violation.
I think it's a well-intentioned fix to a problem that is a problem, but I think there's bound to be some innocence sort of swept up in it, like yourself.
Yeah, but I understand where they're coming from.
No, I wouldn't go that far. I mean,
I reduced it. What, you wouldn't go so far that I understand, or that?
No, you said you're innocent, like you.
Oh, the innocent part. I knew there was something in there negative. So
very important. So at this point, you're gonna do what? You're going to market them how? I mean, because if nobody looks for those keywords and nobody knows to look for that name.
So how am I going to market this? Really, what I'm going to do is I'm not going to focus on the individual apps. I'm going to get further along in my goal, and then I'm going to start talking about that in specific outlets and say, hey, this was my goal. This is how many I've gotten done. This is how I achieved it. Start talking about that kind of thing, answering questions like the one you asked me, like how are you monetizing this, or what's going on with these? Why do these seem so similar to each other?
And how are you going to monetize this?
So how am I? Yeah. So these first 5 are actually the first 4. I take it back. Are ad-based games, and I did an experiment also with this, which I will talk about later. Probably write like a short article. And what I did is you play the game, and it's got a banner ad at the top and a interstitial ad every once in a while when you get kicked out of the game back to the menu. No, I take it back. Only banner ads. And if you want to get, the problem is you're playing this, and if you look at the screenshot, the banner ad basically pushes this whole bit down. So it gives you a little bit less play space, and you can't really see what's going on quite as well. So, but if you want to get rid of that, instead of approaching it the normal way, which is give me money and I'll turn off the ads, I basically give people the option to watch a Vungle video, and that turns off ads in the game for 10 minutes. So watch a video, turn off the ads, then you can see the entire screen. It makes it more playable, a little bit more pleasant. So if people don't want to pay, fine, there's ads. People who want to watch one video and play it for a while, which is probably 10 minutes anyways, also good.
That's an interesting mechanic to do the time-based thing. Now, do you include an in-app purchase as a third option of, hey, I love this game and I want to unlock it forever?
Yeah, I chose not to simply because last week we were talking about this. I think we said it a few times. You get to a point when you're developing your game and you're like, I got all this working, but I would really like to be able to do this one more thing. Do I go do that, or do I just pull the trigger and release? And at the time, I was having some problems with my in-app purchase module, so I said, forget it. I'm just going to pull the trigger. And then I got that fixed, and I went to a different monetization scheme for Red and Div 2, which is it is interstitial ads that come up occasionally, and then the in-app purchase to disable the ads. And I took Sergey's advice. Actually, Sergey gave me some feedback on this game. I kept the coloration. He didn't like the colors, or he thought the colors were bad, but I like it. I'm going to stick with it. But one thing that I did in this game, so this game, like I said, is this navigation game where it's an endless runner type of game. You're going up here trying to avoid obstacles. Basically, you hit anything red, the game's over. Pretty simple. Red and dead. One thing that you can do to change this game is you can have more or less fuel as a challenge. Now, previously, I had thought I was going to do an in-app purchase to purchase more, enable more fuel, but Sergey pointed out that basically that was paying to win. So I went to a system where you can basically you play until you reach a certain level, and it unlocks more fuel. And then you play at that level, reach another level, unlocks more fuel until if you play it and enjoy it, you increase the ability to go forward, basically.
And so you said play to win. So that's an interesting concept.
Paying to win?
Paying to win.
Yeah, it's something that is very frequently seen in today's in-app purchase.
I'm just thinking about a big old button that says pay to win.
Let's not go there. Let's not go there. So, anyways, just released.
It would be an interesting social experiment. You just make a game with the shiny red button.
Yeah.
Pay to win. I
You
know.
like winning? 99 cents, and you get to be a winner.
That's right. You are the winner.
I've considered it, my friends. I have considered it. I've been disillusioned enough to try it, but almost try it.
But no, I like this game. I've beta tested it as well, and I did have a little bit of a mental difficulty with the mechanic, of launching.
I took your feedback too, Charles. I changed the tutorial.
Well, yeah, I think once I got the hang of it, once I understood exactly what was going on there, then I was, then it was a joy to play, right? I was like, oh, now I see the point. And over there, right on there, click on the last, I guess maybe almost the last screenshot there, where it's got the next one. Yeah, that one. That one right there. Believe it or not, I spent a lot of time just trying to get the square through that opening right there. And that's because I didn't, at the very first, I didn't understand how to manipulate the power settings for the block. So getting it through that opening for me was torture.
Mm-hmm.
But
another thing I did that I very big experiment for me, I'm going to do this again, is video tutorials or video hints. So when you mess up, you die a certain number of times or you make a mistake, there's certain trigger events. The game will one time only for that session play a video saying, hey, you made this mistake, this is what you did, don't do it.
The guys from Digaway did something like that, right? I think.
I was inspired by Digaway.
Yeah, and that seems to make sense, right? I mean, you don't need to give somebody an in-depth tutorial if they can just sort of get it. But if they don't get it, now it's the time to help them along.
Yeah.
Would you do a video like an actual video MOV file or something like that, or would you
Yeah. So
do
it's
just a animated GIF or
MP4.
something?
It's an MP4, and what happens is a little pop-up comes up here. It doesn't take up the whole screen, and it's got a little title that tells you basically like this is what you did wrong,
Yeah.
the mistake you made, and
Yeah.
then a video plays in the middle, and then some more text at the bottom that says this is how you resolve the problem.
But I guess my point is, would you would you just create an animated GIF or something like that?
No animated GIF. Did you say?
Yeah,
No, you
something
can't play those.
maybe a little lighter weight.
No, you can't play an animated GIF in
No, but
Comet.
it's something I've thought about myself with tutorials. Sometimes it goes, okay, well, do I pre-render a video, which depending on the size of it could potentially bulk up your app, or I said, do I hard code progression of events in my, within a scene, basically? Do I recreate this, in code?
Well, or you could do a sprite sheet, right? So you could have, talking about the animated GIF concept, you just have a series of images that you flip through, and then that's a video, air quotes. Just curious, just looking for, I mean, what's the size of the video? Maybe it's.
There's 4 videos. I'm showing you on the screen here. There's 4 videos. There's actually more source code, and they do pump up the size. They're about half a meg if you add them up.
Yeah.
So, yeah, they're fairly reduced.
Yeah, but you still wind up, image-wise, you probably still wind up equaling that, right? Doing some sort of.
You can't avoid it if you want to have any fidelity whatsoever.
Right.
So that's it, man. And then I got more stuff coming out. I got my system in place for monetizing or putting menus on or whatever it is I'm going to do. There's one more thing I'm doing. Haven't got quite worked out. It'll come out of this next game that I'm talking about, the one that I'm working with the other person on. No names yet. And that is the ability to store and retrieve levels from a server.
Oh, cool.
That's a big one. I also got an input from Sergey on that. On this game, he said that I should approach this game by allowing people to create levels instead of just generating random levels. And I agreed, but I was too far along to do it for this one.
I don't know if you guys saw any of the live E3 coverage, but creating levels was actually a kind of a recurring theme. Nintendo did it. They have a Mario, we'll just call it level creator. They call it, they click it Mario Creator or something like that. But you can create levels, and then I think EA, their EA Vault Access, whatever, they were doing something, and then I can't remember all the names, but some of the big console titles are all doing. Where you can create levels and share them online, and I think, I know Fallout 4, they're actually allowing people to create mods on their PC, and then people can play those mods, in the.
And they'll sell them on Steam.
Console.
I mean, no, we're not going to sell those on Steam.
Well, there wasn't any mention of that, of course, but sure, yeah, I'm sure the rest of that.
The fiasco.
Yeah.
Well, they're getting ready to do, speaking of Fallout, I think Bethesda is also doing a new Doom, right? Which is like the original, right? I mean, WAD files and all of that. I mean,
right.
Showing my age here now.
Yeah, some good stuff. Anyway, I don't know if you guys saw any of that, but we watched the live Bethesda announcement for Fallout 4, and it was good. So it's interesting. I'll tell you what's interesting is to see right now YouTube is streaming live the sessions from E3. And it's very much live coverage of the event, almost like sports events and stuff like that. So it's kind of cool to see that progressing like that. Anyway, all right. Well, let's talk about Rag Doll.
All right. Let's talk about what I call physics fun. So first of all, this is probably going to be a multi-episode topic. We're going to cover what we can today, and we'll come back to it when we so choose at a later episode. And when I say multi-episode topic, I mean that I think we'll probably revisit physics and add more to the sampler that you're going to get. So people watching the show will be able to download what I'm showing them today, And I think in the future that we will add additional examples and refinements to this, so the list will get larger and larger. I also invite the other panelists who want to talk about physics, have something that they'd like to demo. And if they don't want to go through all the trouble to package it up themselves, simply do the demo, send me your code, and I will incorporate it in this sample kit for people to look at and give it a menu button and the whole deal, and probably package it up a little bit. And of course, I'll give credit, but my goal here is to get stuff together for other folks who are learning about physics and just want to play with it to look at, because it's a broad, deep topic now. So before we start, the first thing I want to encourage people to do is don't forget that the right place to start on any topic in Corona, especially physics, is in the documentation. A great starting point is simply to go to the daily API link or the current APIs. And the way you want to navigate this, if you're not familiar with it, is it's got a sidebar here that shows you all the libraries and all that. It's also got this section where everything is broken out by library and functions and fields within those libraries. So over here, if I was looking for, say, set gravity, oops, I could just do a search on the page, and it would pop right out. So I see people in the forums having a lot of problems finding stuff or knowing how to search docs, and they should start here and simply
that advice,
what they're looking for.
That advice is so good. I mean, I think I responded, I think it was this morning or last night, to a forum post where somebody, I mean, this guy actually knew what he was looking for. He said, you know, how do I get the velocity of an object? I said, oh my goodness, you're using the right terminology. You just go here and command F it, man.
I think people frequently jump into the forums and jump into the site, and they've really missed the link that says, here's the API. Here is the doc, because we have really wonderful documentation. I feel like
it's so much better than it was 4 or 5 years ago.
Sir?
It's so much better than it was, I guess not 4 or 5, but 3 or 4 years ago.
It's not perfect by any means, but it's lots of examples, well organized, well cross-linked. Anyways, accolades aside.
Brent works on that constantly, every week. I mean, he's always updating it, always revamping it. You know, because it's not a static thing. You know, as the SDK changes, and other, you know, not just the SDK, but, you know, Facebook changes their rules or something, or, you know, some network goes away or gets added or whatever, then that documentation has to be updated. So it's not just.
And I think one important thing that Ed sort of mentioned, but is to check the dailies, because there's 2 different versions. There's the stable build and there's the dailies. And for most things, they're nearly identical, which is why I think the dailies are just the ones to go to.
Because I primarily use the dailies. The only thing is sometimes the dailies actually lead the release. So because the dailies are updated as part of the build process that occurs before the release happens, and what can happen is they partially pull the trigger on a release, and they find a bug, and then the release never happens, but the documentation gets out ahead of it. So, you know, you occasionally get a run into, you're like, hey, that doesn't work. Yeah, that's because it's in a feature that isn't quite released yet. But I still prefer the dailies.
Yeah, and I think it's so worth just going there. I mean, it's a admittedly nerdy pursuit, but I guess on a podcast called Corona Geek, that's you know, I think just go and scroll it, because something that I think Corona Labs is not always the best at is trumpeting when they do throw something new in, or maybe they're being cautious about it because it's, you know, still in progress. But every now and again, you'll go there and see something and find something you didn't even know existed. And
it happens to me all the time.
And it'll trigger.
Exactly that. I just crawl this to see what's new.
Yeah. Actually, I just saw one, JSON Prettify. I've got to look at what that is. That wasn't there last time I looked, and it sounds awfully.
It sounds useful.
It sure does. Who doesn't like pretty JSON?
All right. So we start.
Put some makeup on myself. Pretty JSON.
And in this case, we're going to be looking into physics. Now, I want to give a little bit. I know people are like, oh, go ahead and just show us the darn thing, but I just want to drive this home. So you're starting at the top level here. You run down to the physics library, which you can select off the left side or out of the body here. Let me find it. Physics. This is going to take us to the physics library. Now, here's a crucial thing. Here's what I see people do all the time. They go, oh, okay, I'm on the physics library. Scroll, scroll, scroll. What am I looking for? Start. Scroll, scroll, scroll. Okay, start. It didn't work. I don't understand. They leap right into the examples, and they skip over all this stuff at the top. So let's back up a second. Crucial. Look at all the stuff at the top. Frequently, they're going to be, when you're on the home, so physics.asterisk, for example, you're going to see a bunch of see alsos, which lead you into very useful guides, like the physics body guide, the collision detection, and physics joints, which we're going to look at today. And then when you drill down to a specific function, for example, let's try a new joint. One of the things that is always in here is that it tells you what the function returns, if it returns anything, and oftentimes there'll be a link right here. So if we click on this, we can get more information about what a link is, what its properties are, what its functions are that are attached to it, and how we can manipulate it. And this is the part where I see a lot of people in the forums asking a question that if they had simply gone to this page and clicked at the top, they would get the answer they needed. So just be a little more patient, or be aware that a lot of this stuff is cross-linked. There's a lot of documentation here. You just need to know how to search it.
And I will also say that this documentation, just like Jason was talking about a moment ago, it's been refined over time, and it really doesn't contain any more information than is necessary. I mean, sometimes you'll come into documentation and it's documentation, on page 17, and this documentation is really geared towards getting you what you need to know to get up and functioning, but not anything, no additional information.
No excessive, confusing nonsense.
No background theory. No, you have to have read this chapter before you. I mean, it's very concise.
Yeah, it's sort of like the best of. May not be exactly what you need, but I guarantee you, most of these examples, you can work from it and get what you need easily.
Yeah.
So the last thing before we start is I want people to be aware. This is sort of like what Jason was just saying. I went back, when I started here in Corona, there were not this many physics joints. But recently I was helping somebody and I couldn't remember. I never remember this stuff. So I look in the documentation and I was like, are you kidding me? I mean, look at all these new joints. One that I found really interesting was there was a joint. Where is it? Now I'm not going to be able to find it. A guy I was working with was trying to draw a shape. And there was this joint here, or maybe it wasn't a joint, but a physics body. Yeah, I think I'm thinking of the physics body now. Here it is. Multi-element, no. Polygon, rectangle, offset, edge, the chain. So a new body type. And I was like, wow, that's really exciting. My point here is go back to the docs, check it out. Dollars to donuts. Oh, if you don't click on the wrong button like I just did. Dollars to donuts. You are going to find something new that you haven't seen before.
Yeah.
And I've just messed up my documentation. I don't know what I just did to my browser, but it's closed up.
No, another cool example is, I mean, when I discovered content to local and local to content, which I think was only introduced in the last 18 months or so, it was like, oh, this simplifies. I had my own sort of hacky workarounds to get those values when I needed them. They're just awesome, and it was something I discovered just browsing at random.
So it is, in fact, all good stuff, and there are a lot of features out there, obviously not announced, but useful to us. So today we're going to go through some examples. We're going to get started talking about two kinds of joints. One kind that is actually crucial to the design, and the other one that I use merely to to provide better feedback. So the two joints that we're going to talk about today are the pivot joint and the weld joint.
And just for anybody who's kind of new to the whole idea of joints, it sounds fairly self-explanatory, but what exactly are we talking about?
Okay, so a pivot joint in any of these joints, a joint at all is a physics, not an object, but a structure in a sense that allows us to link two or more objects to each other. As your shoulder is a joint for your bicep, connecting it to your clavicle, is that right?
I don't know.
As your shoulder joint connects your arm basically to your shoulder, joints themselves can be used to connect two or more objects to each other. And there are a variety of different kinds of joints. Let's go back to the list. There's a pivot joint. A pivot joint allows one object to be connected to another object and to rotate freely around that joint. In other words, once connected, object B is allowed to rotate, pivot around the joint.
So maybe
And
like
joints,
maybe like an axle or something like that, or
like an axle, very much like an axle.
Okay.
Additionally, pivot joints can have no motor, which means that they're allowed to pivot 100%. There's no limitation. There's no power in a sense. It's not turning. Or you can set a limit, which says the pivot joint's only allowed to turn between, say, 50 degrees and 90 degrees, and that's the range it's allowed to pivot around, and then it's restricted after that. It's stopped. Pivot joints can have a motor in a sense, and what this means is that when enabled, it has a certain amount of torque, and I'll show this to you, and it actually rotates the joint, which then rotates the object that is mounted to that joint. So let me go back to the picture. B is mounted to A. It's a little bit hard to see. Right here in the center on this anchor or pivot joint. And if this were a motor pivot joint, what would be occurring is that the pivot joint would be turning in one direction or the other, and B would be forced to rotate with that pivot. In addition, we have distance joints, which is the job of a distance joint is basically to keep two objects linked to each other, but at a certain distance from each other. Piston joints, I'm not going to go into all of these today because they really require a more detailed coverage than what I can tell you, but you can certainly read through them. Charles I think he's exploded in the background there. So the only other joint we're talking about today is the weld joint. Now a weld joint is exactly like a pivot joint, except it's not allowed to rotate. Weld, as it implies, basically says object B is connected to object A, and if object A moves, object B moves. If object B moves, object A moves.
kind of like the old Roadrunner cartoons, where he throws the anvil off the cliff and he's tied to it with a rope and it jerks him off down into the ravine.
Exactly, except in this case, the rope would be a rigid connection. I see what you're saying. I just don't want people to get confused.
Oh,
This
so
is exactly
it
like
is
that.
different. It's not a piece of string. It's an actual.
Right. It's not
rigid.
flexible in the sense that it's not allowed to. The distance between A and B is always maintained. The angle between A and B is always maintained. So if A rotates, B will be forced to rotate around this axis along this arm. Okay, so I'm going to show you a demo, some demos of things that we're not going to get to talk about them all today, but you're going to get the code after the show, just to show you some of the things that you can do just with a weld joint, or I'm sorry, just with a pivot joint. There are weld joints here, but they're not actually used for anything in the demos as far as like physicality. They're purely used so I can give better feedback to show you something. I'll explain in a moment. So we start this with the simple joint, which is just this arm here is attached to the block in the middle, and as I drag the green part, in all of these samples, if it's green, you can touch it or click on it and drag it. Now, this center box here is a static body, which means that it's not allowed to move. So I can drag on it, it's not going to do anything. However, you can change the code and make it dynamic if you wish. Another thing you're going to see in all of these demos is they have a button, one or more buttons in the upper right corner. So the first one you'll often see says gravity. It's a toggle button. If I click it, it turns on gravity for the scene. And now you can see how gravity affects basically this arm. connected to this static object around this pivot joint right here where the gray circle is. You can turn it off, and now it's free running again. All of these are designed such that you can click the back button and then click the demo button again, and it redraws the scene fresh. So whatever you did, however you manipulated it while you were playing with it or dragging it, you can simply click back, go back in, and it's a new example, fresh. The next thing we're going to look at is, we'll probably get as far as starting to look at the mechanics of doing the draggable doll. And a draggable doll is nothing more than my very poor representation of a human body with a torso, this green bit here, a head, a bicep, which is this part here between the gray and the red, or the gray and the blue, and the forearm, which is the green to the red and the green to the blue. Again, green is draggable, white, blue, etc. is not. Whoa, come back here. All right. And that's why we have the ability to reload the scene.
Goodbye.
Okay. Thigh, calf, foot, knee, etc. These are all named so in the code to go with, basically the body parts. So you can drag this guy around, fling him into the ground,
Ooh.
beat him all you want, and then you can turn on gravity and see how he behaves, or it behaves.
You're a cool master, Ed.
All right. So it's one step removed to take this exact code, and it's then we integrate this with last week's topic, which was what? Saving data to a table.
Persistent.
Yeah. So imagine, if you will, you want to make a game where, and okay, I have to admit, I did work for a guy, and I cannot tell you what his game was about because we never completed it, and we're still under NDA. But I can tell you that it involved the mechanics of a doll and posing. I just can't tell you more than that because that's simple enough. And this is a very intriguing idea. I really like it, and I'm going to do something with it myself someday. I just don't know what. Anyways, I wanted to demonstrate the power of taking a rag doll and the topic from last week. And basically what this does is you pose your doll the way you want it. Let's just do this. You click the save button. And when you click the save button, what's going to happen is a little tiny piece of code that's maybe like 4 or 5 lines long, maybe 10 at the most. I don't remember. I'll have to look. It says, find every piece, and I've stored them all in a table or referenced them. It says, get the X and Y position, get the rotation, save it to a file, and now, if I move my guy and I click restore, what it does is it loads that file off the disk, finds the names of all those pieces, and then applies the X and Y and the rotation back to this doll. So we just fling him over there, restore. Change the pose, save it, restore. Turn on the gravity, restore, 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 restore. And this is literally like, I don't know, 20 lines of code added to the previous portion of this example. Everything else is the same from the draggable doll, except now we have the ability to save and restore poses. Now, if you're really intrigued or want to take it to the next level, you can take what I've given you here. What is going on? Oh, I have done something bad. Okay.
Too much clicking. I have an idea for an app based on the posable doll. We can talk about it in a little bit.
Okay, good. We can talk about that in a little bit.
Yeah.
But what you can do is you can save. Why not save more than one pose? And then you could create your own little. You don't need some really fancy animation program. You could literally pose your guy and say, make this, pose it this way, and instead of instantly snapping to the other pose, you could use a transition over time. So example, let's try this. You move the arm, you save a pose. You move it again, you save another pose. Then you play it back by transitioning from one pose to the next pose to the next pose, and you've created an animated character all in Corona in very few lines of code. Now, obviously this is not a replacement for other techniques, but it's...
No, I mean, what you just described is almost sort of like a poor man's spine. I mean,
It is. It's a poor man's spine. Exactly. And spine being the tool, which is a wonderful tool, which I use. But, it depends on what you need to do in your game. These are the kinds of things that Corona, as an SDK, allows you to do. All right, last demo, and then let's actually go look at some code. The thing is, that really sucks about doing these demos for this show is I do them, and I'm like, hey, that could be a game. I get these game ideas. So the next one is make a car. So a car, your basic car, is nothing more than a block and some wheels. Now these wheels are attached to the block with a pivot joint. And if we turn on the gravity, the block falls, and the wheels turn, and it does pretty much what you expected it to do. The only other thing that I got here is I hooked up the ability to turn on the motor. So if you click the left button, what's going to happen is this wheel, the motor will be turned on for the joint, and the wheel will start to spin to the left. Or you turn on the right, and it goes to the right. Or you could turn off gravity and let it float around for a bit and play with the thing and turn it back on.
Cars.
Or you could go left and right.
you've heard it here, folks. People for ages have asked, when am I getting my flying car?
Exactly. Here's
2015.
your flying car. So I don't want to go too much further with that. And I think it's time to look at some code before people get disappointed that I didn't cover any code whatsoever. So let me bring up the code. First of all, what you're going to get is you're going to go to the Hangouts, Corona Geek, Git. I will give a link to Charles to give you a direct link, which will allow you to download a file called physicsfun.zip. It'll be under the I can make that section of the Hangouts on my Git account. And underneath here, you're going to find main, config, and build settings, the traditional files you find in all projects. This project does use SSK. However, I have not used it to do any of the implementation of the actual dolls. This is all in what I would consider pure Lua code or pure Corona code. So it's longhand, so you can see exactly what's going on. There's a scripts folder, doesn't have anything in it. Not now, anyways. Images folder, where I've got some basic images of just simple art that is used to make this demo. And the interfaces folder, which has got all the different samples. For example, the car, the doll, the posable doll, etc. And this will grow over time.
So one of the things I see here, and you may talk about this in just a moment, though, is for this sampler, there's the functionality that you're trying to convey in terms of the joints or the ragdoll or any of that kind of stuff. But there's also how the sampler itself is constructed. So if you download this code, don't just take a look at the functionality for the physics. Also look at the structure of how the sampler is put together, because there are scene transitions there. Files are organized into folders. A lot of the common questions that people have about how do I organize my project, or how do I work with Composer, or how do I do some of these basic things, they're encapsulated in this example as well. So just be aware of that.
Yes, thank you. Thanks, Charles, for mentioning that. I want to say that the framework that's used for this particular project, SSK Corona is out, the new one is out, the sampler is out. One of the things that I promised people I would do is put together a Composer framework using SSK, and that is in progress. And I've taken the in-progress copy of that and used it to make this demo. So what you're seeing here with the layout of the main menu and the splash screen and stuff like that, it's the beginning of what will be eventually a free template that people can use to start with SSK with Composer and go from there. It'll come with a splash screen and an options screen, but not all of that is yet in here. Still, it has most of that layout present.
Yeah. Nice.
So let's take a look at simple. Simple, one thing you should know is simple doll, and posable all have pretty much the same code in them, but it's just the part where I do the work to draw the scene that's different. Because I wanted to lead people through progressively explaining what the code does and what my custom bits of code do. And I figured not changing it from scene to scene would make the most sense. So let's take a look at simple. And if you'll recall, let me bring it back up here. Simple is I'm drawing a square in the middle of the screen. I'm giving a physics body, and I'm saying it's static. So when gravity is turned on, or if I drag it, this body is not allowed to move. That's the key thing that you have to understand about a static body. Not allowed to move. Additionally, let me go back and reload this. All throughout the code for the doll, I have a function whose job it is to draw limbs. There's one for arms, one for legs. And what it does is it takes inputs to tell it how long the arm or leg is. And then what it returns is a rounded rectangle, which is what you're seeing here, which is the white part. And then welded to it with a weld joint is a circle on the left and a circle on the right. And the function itself returns a reference to the rectangle, a reference to this joint, to this object, and a reference to this object. And then having those three parts, I can use the information and say, I know where this position is, so I'll make the next arm starting over here. And then it just makes it easy for me to create these simple linkages. So we're going to demonstrate calling this once to create a single arm, which in this case is just this little bit here mounted to the static. You might want to mute your microphone there. It's, whatever's happening is taking over the camera too. Or Charles can take care of that. Sorry about that. All right. So anyways, let's take a look at the code. All the code's going to be organized the same. It's a composer scene, and you'll see my normal stuff at the top. But it's not the splash screen. I put the wrong comment here. We load composer. We create a scene. We load the physics library. I set up a bunch of variables. I like to set mine up at the top. There are some localizations, which means that I dereference some functions and put them into locals. Now, most of these I'm not actually using in this file, but I didn't want to delete them. I wanted to maintain the standard structure of this file. The important bit you're going to see will be not the create scene. The create scene for all of these examples creates the title, the buttons, and the background, but it does not create the block. It doesn't create the arm. That is created in the will enter scene method. Now, will enter is not a standard composer scene method. It's something that I wrote. Go down to the bottom of the file. I have the traditional composer show and hide methods, which then looks into the event and says, is this the will show or the did show? If it's the will show, call will enter. If it's the did show, call did enter.
And
the reason
okay, go ahead. Yeah.
The reason I did this is because this is the structure that was followed by the previous one, which was what was prior, a storyboard. Storyboard had the will enter, did enter concept, and so I followed that in Composer because it just was a nicer transition. I also like it because there's no question if you use my framework, where is it, and you put some code in the will enter, it's going to get executed when you are about to enter the scene, not when you did, or it's not going to get executed twice. People in the forums make this mistake. They use the show method. They don't look at the will or did part, and then they're surprised when the code executes twice.
Yeah, that is a confusing piece.
So if you use my framework, confusion goes away, as long as you understand what I've done. Okay, so what do we do here? First thing that happens is I start physics. You got to start physics before you can do anything else with physics. Then I set gravity to 0 because I want to start off with no gravity in this scene. And then I set physics to continuous. This is not necessarily what you don't necessarily need to set physics to continuous for this example to work. Physics being continuous is basically telling the physics engine to continuously reevaluate the relationship between the different joints and other objects with each other. It's a much more intensive application of the physics engine, and so you probably want it to be false unless you absolutely need it. In fact, I will probably commit this with all of these commented out, and the default case is false. And then if you run one of these examples and it doesn't feel like it's behaving properly, you may want to go back in and set that to be continuous. But I think that is, as I said, I derived some of this from some work that I did previously and made quite a number of changes and rewrote most of the code, but I left that in. So I will come back and talk about continuous versus non-continuous on a future episode. For now, it's going to be commented out when I commit this. Okay, one of the things we're going to be doing a lot in each of these examples, let me find the simulator again, is we're going to be creating display objects, and then we're going to be attaching physics bodies to them. However, when I'm making the draggable doll, I don't want these body parts hitting each other. So there's two parts to physics interactions. There is a collision detection, which is you can set up some code that detects whether or not a collision occurred. However, if you set up a basic physics body and you don't specify any details about filtering, etc., which I'll discuss in a moment, then every physics body will collide and respond with the other physics bodies. And what this means is if I had not done this group index filtering, and I'll talk about it a little bit more, what would be occurring here is all of these body parts would be hitting each other, and this doll would just be like wacko. In fact, let me see if I can just make this just show you what this looks like if I don't do this.
His forearm and his upper arm or whatever are rectangles, right? So they're at some point they're actually, the angles are actually interacting with each other.
Yeah, these things are all overlapping each other.
Right.
At the joints. And you can see I'm not touching this at all, and it's just going crazy. What is occurring is these body parts are now they're hitting each other.
Why are you hitting yourself? Why are you hitting yourself?
Yeah. How are you hitting yourself? We turn on gravity, you can see the behavior is all wonky. Like the arms, the legs no longer loose. Oh, that was not a good kick. Oh. So anyway, what we want to do is we want to say, don't hit yourself. Don't allow any of these body parts to hit each other. And the very easiest way to do that is to create the physics body with a filter and then set this magical property, group index. Sorry, I forgot to turn off my ringer. Set the group index to -1. In a nutshell, what that is saying is all physics objects created with this filter will no longer respond to each other. They can still sense that they've collided with something, but there'll be no response. The response is the part where the physics engine says, now do something. And typically the response is, don't allow two physics bodies to occupy the same space. In other words, if you hit one, push it away, or at least keep them from overlapping. Does that make sense?
Yeah.
Okay. So I'm juking and jiving over here. So here's my filter, and in my code I set up one filter and I just use it over and over as I create the bodies. Alright, now the next bit of code. Let's go to simple. So here's our filter. Now I create a table which I created a reference to way up above in the code. So this is a locally visible variable visible below this point to all the code. And what I'm doing is not so useful for simple example, but it will be more useful later for the posing example, is it's basically a table, and every time I create an arm or a leg or something, I'm going to put it in the table. So I have a big list of body parts, which is what it is. It's the body parts. Now we get into the control bits of the code, which I encourage people to play with, although it may make the examples a little bit wonky. For example, neck length, that has nothing to do with the example because there's no neck. But segment length, on the other hand, is totally reasonable to change. Currently what this is saying is this white part right here is 100 pixels long. If I wanted to change this to 200, change this, save it, reload the project, rerun it, and now the arm is 200. So by changing these, you can start to understand the relationship of the bits of code that you're seeing in this file. Another thing is we've got segment length, which in the future I will either call it arm length or leg length, something like that, to be a little more specific to the code that I'm writing. But in this case, segment length and segment thickness. Now, thickness is how thick through the body this piece is. So if I said instead 45, save it, load it, run it, now I get this big thick block. So this just gives you stuff to play with to see what I'm doing. However, let me explain what is going on in my original code. What I've done to implement the posable doll, the draggable and posable doll, is I've created a rounded rectangle. Now you can't see it because these dots are in the way, but what this is, if you will imagine, is a rectangle that has nice rounded edges on both sides. So it goes around and it's all rounded, perfectly rounded. And the point of this is if you round them like that, it makes a nice sort of like joint, juncture area where when it rotates, it doesn't look too ugly. Now it's a little bit offset. I think I've got this arm segment a little bit too far to the right along the bicep, so it should be connected further out, in which case, if I did it right, when you rotated, that little bit of arm segment there wouldn't be showing, and this would look nicer. So I rounded it so that you can rotate around and make it look nice. So that's the joint radius. That's basically telling us how what the curvature of the rounded rectangle end pieces is. So then to calculate the thickness, all I needed to do was take the joint radius, the radius of the turn, do a little bit of math, multiply it by 2, and then I subtracted a little bit off the end just to make the thickness a little bit less. So for our simple joint example, I could manipulate the thickness simply by changing the curvature. So let's make this 24 instead. You run it, reload it, and now we got this kind of blocky, it's not quite right anymore. So you got to play with these numbers to get these curvatures to come together.
It's an interesting effect nonetheless.
Yeah, this is all manipulatable code that you can just play with. No neck length, so let's just take that out of there. Alright, so let's get to the actual code of making things. First thing we're going to make is the cube. In fact, I'm going to comment this code out as we go along just to make it easier to follow. We're going to reload the example. A cube. This cube, I put it right in the table by saying parts.cube, so that gives it a name cube as a field on the table. And then I create a new rectangle. I put it in a group, layers content, which is a group which was created up here. Uses SSK to create an underlay, a content, which is above that, and an overlay, which is above that. This allows us to separate our inputs, like the buttons, and the background image, which is this just checkered bit right here. And then in the content, that'll be where we put our blocks and our arms and stuff. So we got 3 layers sorted nicely. So back to the creating. So this first argument is a display group. Then I say start at 0. So the x is 0, go 40, basically be 40 wide. start at 0, 40 down, 40 tall. This is going to make a square that is 40 by 40. Then I take and position it by saying cube x is center x. Center x is an SSK variable that comes along for the ride. It's a global variable. It is always the center of the screen. Pardon me, drink of water there. Then I set the color to 110, which is the color code for yellow. If I wanted it to be cyan, it would be 011, I believe, for people who know their color codes. Hopefully I do. There we go. Now it's cyan. Or I could manipulate these between 0 and 1. Any value between 0 and 1. This is the red channel, the green channel, the blue channel. Right. Next, and this is a very important part, I use the physics library add body function. I pass in a reference to the cube, which I created above. I tell it that I want the body type to be static, and I want it to use these parameters to set up the details of the body. I'm going to give it a density of 1.0, which you need to specify because I'm not 100% sure, but it used to be that the density was arbitrary. I don't think it was set to default to 1.0, and so you could get sort of like weird behavior when you expected it to be 1 and it wasn't actually 1, because the density of the body is going to tell the physics simulator how to do math on this in terms of how to affect it with gravity, how the inertia changes. So a lower density means a lower inertia, that is easier to start moving, easier to stop moving. Then there's the filter, which is a parameter that is passed in, and I simply pass in a same named table. I could have called this my filter to make it less ambiguous. It would be like this. So the table is passed in, and it tells the physics engine, use this filter parameter, which is group index -1, and that's telling this body, anybody else, any other object created with this same filter will not collide with me. Okay, now there's a little bit here that's kind of confusing, perhaps. The static object doesn't need these parameters, so I'm going to take them out. Yeah, I'm going to take them out. We'll talk about this more when we get to the doll. But what I was doing here basically was changing damping properties. So linear damping says how quickly does a body slow down on its own when it's in motion. If the damping is 0, it will never slow down until it hits something. But if it has a damping greater than 0, there will be a force applied to it as it is moving, which causes it to slow down. Now, if gravity were turned on, it would continue to accelerate downward if gravity was pulling it down, but damping could sort of slow that down, change that effect a little bit. But it would never stop it entirely, because gravity is a continuous force that's applied frame after frame, and the damping can only negate part of that. Angular damping is just what you would expect. So linear damping is moving in a line, slowing it down. Angular damping says when the body is rotating, if angular damping is 0, it just rotates forever, never slows down. However, if it's got an angular damping greater than 0, it says take a little bit of that velocity off, the turning speed, frame after frame after frame. So more and more is reduced as it goes along until it stops turning. In your games, you're probably going to want to have some linear damping and some angular damping, depending on how you want physics bodies to move and behave. And I have to tell you that making a game with physics, you're going to spend a lot of time tweaking these parameters to get the motion correct versus the other inputs like forces and gravity and stuff. And so you can spend a lot of time messing with this to get it feel just right. But to me, that's the fun part, is the tweaking of the physics to get it to work just the way you like it.
So what I'm hearing you say then is there's not like a formula where you say, oh, well, if you want it to behave this way, then you go in and put this much linear dampening on it.
You know, there probably is a formula, but I have never done. There is actually a physics formula for it, but the problem is that the physics engine in Corona is sort of a black box. I don't know what the code on the inside looks like, so I can't see what math was done. I can only guess.
Okay.
And I haven't spent the time to evaluate that, like put in 5, put in 4, do the math, see what the difference was, try to figure out what the curve is. You know, I could do it, but I could just as easily tweak it and sort of get used to knowing that 2 is more than 1, and 3 is a lot more than 2, and so on and so forth.
And there's a lot more, and there's another subjective part, right? Which you said just a moment ago is, to kind of get the feel that you're looking for.
Yeah, absolutely. You know, at the end of the day, you would not be objectively designing this unless you were trying to create a perfect simulation. You're doing this to make it feel a certain way for fun, and the fun factor is all in the mind of the player. So tweak away. All right, I'm going to turn this last bit off and turn it back on. I know we're way past the time already, but I just want to finish this out. There's a parameter called isSleepingAllowed. I'll explain it, and I'll come back to it. Physics is a very computationally expensive feature in any game engine or SDK. But one of the ways that a game engine can reduce this is allow the physics engine to stop running if it's not needed. And so that's called sleeping. So what can happen is, let's say you create a physics body and there are no forces acting on it, no gravity. You haven't touched it. It hasn't been hit by anything. What will normally occur in torque is, if you have a dynamic body like that, a body that is allowed to move, is it will be created, it will be what is termed awake, and the physics code will be running. It will be evaluating. It will say, do I need to move this? Is anything occurring? Has it been hit? Etc., etc. All these heavy-duty calculations. But if it's allowed to sleep, a few frames later, what will occur is the engine will say, nothing has occurred with this physics body in the last few frames. So it's likely that nothing will occur in the next few frames. I'm going to stop evaluating this object. I'm not going to try to move it. I'm not going to see if it needs to be repositioned. It's basically just sitting there doing nothing. So I'm going to ignore it. Now, this can get you into all kinds of trouble. However, it's mostly a good thing, because sleeping will be turned off immediately if a collision is sensed. So if you have a body A and a body B, body A is not moving, body B is moving. Eventually body A will go to sleep. I'm holding my hands up like you can see me. Body A will go to sleep. Body B moving, it's not sleeping. It's continuously being evaluated by the physics engine from frame to frame. And so as soon as body B gets close to body A, the physics engine will say body B is about to hit body A. And then it will also say, oh, wait a minute, body A is asleep. It needs to wake up again because I'm about to interact with it. It's about to get some action. And so by the time body B collides with body A, it will be awake again. Body A, will be awake again, and everything will function well. Now, I said that sleeping can get you in trouble, and I will demonstrate how in a minute. But let's make the pivot arm first. So the pivot arm, which is not the right arm, let's just call it the pivot arm. This is what happens when you write demo code really fast and you copy and paste. You leave comments in that make no sense. So what I'm going to do first is I'm going to uncomment this bit. I'm going to get rid of all this code. There we go. And I'm going to show you how this function works, the create arm segment. Let's rerun this, reload it. Without looking at the code, what's occurred is we created our block like we did above, and we called that function create arm. And what it does is it creates this rounded rectangle with 2 dots which are welded to the end. They're using weld joints. So if this arm were to move around, these dots would move with it. Now, the reason I did that was both to give me objects to reference as the position of a joint, but also to give you visual feedback. I would not suggest, when you create your own games, that you create little circles welded to the ends of the arms. Why? because let's think about this. We got a head, torso, two leg segments, two more leg segments, two arm segments, two arm segments. These all have physics running on them. By adding additional bodies, here, 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 all these dots, those also have physics, and they also have weld joints. A weld joint costs you computation, because if the arm moves, the weld joint says, hey, move the hand, or the dot. Or if the dot moves, it says, move the arm. And it's attached to this. So now I got to evaluate that weld joint, and this weld joint, and that weld. It's a lot of extra computation. I did it in these examples purely to give me something easy to reference in my code and to show you the body parts very clearly so you could sort of see what's going on. In fact, if this becomes a popular topic and if people give us good feedback on this, what I can do is provide a variation on this example that does not have the weld points in it. So you can see what a proper looking doll looks like without the extra circles and the weld joints. Nonetheless, purely for feedback and ease of manipulation.
There's also a rag doll example included in the sample code with Corona. So I don't, without looking at the code and comparing them to what you have there, that might be an option as well to go just look at the sample code.
That is actually good sample code. Mm-hmm. I'll tell you what the difference is. The difference is that whereas I draw my arms using one line of code, they draw their arms and their legs using several lines of code. And so I chose this way because even though it looks complicated, it's quite a bit simpler to read once you understand the format than what they did. And mine's a little more, I don't know, I feel like I can reposition the arm in less effort. It's a either or kind of thing.
Yeah.
Neither is better or worse. It's how people approach code. Okay, so this call here, I know we're on the clock here. I'll go quickly. We won't even really dig much into this. Basically, what this is a function that takes a group. I'm going to tell it an X and a Y position, which is where I want to place the center of the arm. Everything is placed by the center. So I need to calculate if I want to move it to the right. I got to say how long is the arm going to be? It's going to be 50 pixels long. Move the X to the right. And then what that'll do is it'll place it by the center, but the center is now 50 pixels to the right. I tell it how long to make the arm segment, which is a variable that we've created above. I tell it how thick to make the arm segment, and I tell it how thick around the what the radius of the joint is. And it's going to take all of this, and in this piece of code, which I invite you to crawl through, it's going to set up another filter. I could just as well have created this globally. It's going to create a rounded rectangle with, this should be radius, but I set it to 12 regardless. It's going to add a body to the segment. It's going to use the filter. It's going to set the density to 1. It's going to position it based on the rules that I gave it up here. It's going to set some damping, which we talked about. Then it's going to create a circle for the left side and a circle for the right side, and it's going to use a weld joint to stick it to the segment, to make it stick to it, so if this moves around, this moves, and vice versa. And then it's going to return the rectangle, the circle, the circle. And with this, then I can start to do assembly. So let's take a look at how I assemble it, and then I'll show you the sleeping bit, and we will be done with me talking for today. Comment that out. Comment that out. All right, so what I said here was I'm going to return a segment, a marker.
I don't think it commented anything.
Sir?
I don't think it commented anything.
Right. Thank you. There we are. All right. So the function is going to return a segment, a marker, and a marker. Let me make this bigger so you can read it. So I'm going to store these. You see I'm using commas. This is a Lua thing. Basically, it's returning 3 variables. So I say put the first one in here, the second one in here, and the third one in here. Okay, so I pass in the group, and then I say get the center position of the cube and add half of the length of the segment, which is the length of the arm thing that we're going to make, minus the radius. It's just a math equation. If you think about it, we're going to take off half the radius, or we're going to take off the radius, because the arm's going to be shorter by that amount. And then we want it to be aligned vertically with the cube. As you can see, we want it to be vertically with this, but we want to push the end all the way to the center. And then all I do is I create a pivot joint, and I attach the marker, which is really the wrong way to do it. Still works. I'll explain. Remember how? Okay, I attach the marker. Now remember, the marker, the circle, is attached to the body. So what I've done is I've attached an arm to a marker and a marker to this. So it's a very complicated linkage. So when this executes, the code says, I got this connection, has it turned. Let's look at the next linkage, and the next linkage, and the next. You're creating this long chain of evaluations, and the more joints you have attached to each other, the more code has to execute every frame.
Right.
What would have been better...
But we're doing this for illustration purposes.
We're doing it for illustration purposes. What would have been better, and what I do in the doll code, is I mount the arm, the white part, instead. Slightly different, but much better in terms of execution speed. All right, so we attach the marker, and we attach it to the cube. So the first argument in new joint is always the object that would be put onto the second object. So if you ever have any confusion, now one thing people will do when they're creating physics joints is they can't remember, is it object A goes first or object A goes second? Think of it this way. The first argument here after the type of joint, this one will always be rendered on top. Even if you had it below, as soon as you do this mount, as soon as you hook it up with a joint, it's going to push it to the top. You don't have a choice here. Now somebody will do the experiment and prove me wrong, because this stuff changes all the time. It gets better. But it used to be that if the render order was different, it would be adjusted, which always messed me up. So remember this. This object is being mounted to this object. This is the master. This is, in a sense, the slave, the child. So if you're creating a long linkage, and this is object A, then this is object B, and then you want to create a C, then C would be this, B would this be argument, C, D, etc., to create like a chain. If you were creating, we'll see this when we do the arm, because it's got two segments, and the leg has two segments. We're not going to see it today, but you'll see that the order in which I do things is the sort of like the center, the next bit that's attached, then this bit will be here, and the next bit that is attached, and so on and so forth. Because you got to get the order right, otherwise the joints are all goofy.
Okay.
All right, and then this part says, physically in the world, where is the joint? Now, one of the things that people mess up all the time is the positioning of the joint. But you can easily fix this problem by turning on hybrid drawing, running the physics example that you're working on, and then you can see here, you can actually see where the joints are. You can see there's the center of a body, there is a joint here and a joint here, and if I had messed up my joint, so let's just make a mistake. Let's push the joint way over to the left. No, let's push it up so it's really obvious. So minus 100 pixels. I run this. Now I got this weird spike, right? And what this is the joint connection is way up here. So it visually appears like it's here, but this arm is attached to this object way up here. And then if I make it draggable, this is freaky.
Oh.
Yeah, it's like it's all wrong. It's sort of doing the right thing, but it's freaking out on me. not what I wanted. And so all of this occurred because I positioned it wrong. We just simply put it back, reload it, and we're back in business. Everything is kosher.
Yeah, I can see how that would be a hard one to troubleshoot because you see the block on the screen and you're like, well, what's going on?
Yeah, when you don't have hybrid drawing mode on, you can't see what all the physics bits are doing. Everything looks good, and then it behaves wonky. Turn on hybrid mode, and you're going to see what's going on. Okay, so let's talk about sleeping, and then well, only half an hour passed on the show, but this is crucial. We'll just forget about the dragger code here. We'll have to get to it on the next episode. In a nutshell, the dragger is using a touch joint. I forgot to mention that. A touch joint is a special kind of physics joint that allows me to combine a touch with physics response. It lets me basically drag. See this? See how this thing is moving around? Nice loose the little green dot is my touch, and it's basically saying as the green dot moves around, act on this body here that I just touched.
So your finger does not have to be directly on the item that was touched.
Yeah, it gives me this nice little anchoring, and I can make see how this thing stretches? I can make the connection between these two stronger or weaker, and what that allows me to do is change when they drag, like how quickly they can drag an object, or how much it pulls on it, how hard it pulls on it. So it can be a weak connection like I've got here, or I can make it really strong, and then it would follow me exactly. Whereas this one's kind of loose and springy. The way I like to do my physics examples is gives a little more flexibility to this. It makes it feel better.
I like my physics loose and springy.
So let's go ahead and get that out of there, and let me show you the problem. So let's go ahead. Is sleeping allowed? And let's set that. Turn it off. By default, sleeping is allowed. Okay, we're running the example. Now, if I click gravity, it's going to turn on gravity. What would you expect to happen? Charles?
Oh, I'm sorry, what was the question?
Okay, so I got this arm. It's connected here. It's all ready to go. It's not moving.
Yeah.
If I turn on gravity, what do you expect to happen?
Expect the arm to, fall, point to the bottom, point to the ground.
All right, let's find out. Nothing.
Nothing.
Nothing. Now let's go turn on hybrid mode. Let me show you what's going on here. Pay very close attention.
Okay.
I'm going to reload this. Yeah, you didn't even see it. Didn't even see it. When this comes in, see how it's gray? Now watch again. See that little blip? Maybe hard to see. If it looks kind of brown, that means it's active. But now it's gone gray. What that's telling you is the physics body is sleeping. And because it is sleeping, changing physics, changing gravity, the body's like, I don't care. It doesn't know. It's not being processed. However, as soon as I touch it, it wakes up. You see how it woke up? See how it's turning gray and brown?
Yeah, the color changes, yep.
But as soon as I touch it, I wake it up, and now gravity works. So this gets people into all kinds of problems when they're making their games like, I'm playing with gravity, it's not working, what's going on? All right, well, first of all, let's turn off the hybrid mode. Well, let's leave it on just to see what happens. And let's go back in, and let's say, because all these objects are connected, I'm just going to say that the marker is not allowed to sleep. Just choose any one of the connected objects. They don't all have to be on. Just any one. If they're connected, and you say sleeping is allowed false, in other words, it's not allowed to sleep, now you notice it stays brown all the time. That means it's always awake. Now if I change gravity, it works just as expected.
And just to highlight a point that you just made there, you're saying that if any one of those is allowed to sleep, then it affects everything?
If any one of those is not allowed to sleep, none of the connected bodies is allowed to sleep. So I didn't have to set not allowed to sleep on the arm and the thing and any of these bodies.
Yeah.
It said you must stay awake all the time.
Mm-hmm.
If it's connected to another body, that body always stays awake with it.
Okay, so it sort of overrides everybody
else's. It's like you got a girls' sleepover, and one girl stays awake, all the girls are going to stay awake.
Okay.
For people with kids, right?
Yeah, sure, right. Yeah, yeah. If they're awake, you're awake.
Or boys, and you're going to stay awake. You're all connected.
Right.
Okay, it was my I tried my pseudo joke, but
Yeah,
I
but
think
that's
people will get it.
but that's worth pointing out because it could be a, you're thinking, well, I didn't apply it to everything. I just applied it to one thing.
Right. So, for example, let's not even change any of the joints on the arm at all. Let's make the cube not allowed to sleep. The example.
Which is really the base of what everything that's.
I'm a liar. They changed this. Look at this. The base is sleeping.
Mm-hmm.
It's not sleeping, and yet the arm is now sleeping. I'm a liar. It looks like any of the dynamic parts have to.
But cube is false, right? Is sleeping allowed is false. Wouldn't you turn is sleeping allowed true?
Yeah. So no, it looks like any dynamic body.
Turn it to true.
I wonder if it's because it's static. Let's make it dynamic and see what it does. There we go. Okay. It looks like the body has to be both dynamic and attached to another body. Any dynamic body attached to another body will keep that body awake if it is awake. But
gravity.
the static body is allowed to go. Yeah, that makes sense actually, because static bodies don't process gravity anyways, so they are effectively allowed to go to sleep.
Hit gravity. Hit it. Hit it. Hit gravity.
Oh, okay. So we hit gravity, and now our whole arm falls off the screen. You just wanted that, didn't you?
I did.
So lesson learned. Sleeping property does not propagate through static bodies.
Okay.
All right. I know. I see you. They're like, what?
That's okay. That's okay. I think we get the point. We got some good info.
So we got a lot more code, and we're not going to get to it today. And I encourage people to take a look. It's pretty basic. I think if you just take your time, it'll make sense. Or you could just simply do what I do, which is just go in here into the car sample and you just keep playing with this thing. And just keep messing with it, and turning off gravity, and then turning back on gravity, and doing the wheels, and doing the gravity.
Well, see, right there, I could see stuff falling from the sky. You have to catch it in the cart, and then if you catch a certain type of material, right, then it dumps your cart over, and you lose all your stuff in it or something. I mean, very simple game.
I'm having fun just playing with this.
Yeah,
this is a new game. It's going to have 4 parts to the platform and a car. Woo!
I don't see why you couldn't publish that right there.
Right there. I'm doing it.
All right. So for next time, we're going to go what? Go through the ragdoll example.
Yeah. So we'll get into the ragdoll example next time.
Okay. Well, there you go.
I'll go quicker because we don't have all this. We've covered a lot of the base topics.
Yeah. And we'll jump right into it next time. We'll get right into the code. We won't do any sort of.
No documentation.
We always say that. We won't do all a discussion in the beginning.
We'll do our intro and our announcements, but we won't have to say go read the documentation because we did that this time.
Yeah, right. Okay, all right. So there you go. Links will be in the show notes to all of this. Everything is here, even though we haven't covered all the code yet. Like Ed said, it's all available to you today to play with. And then if you have suggestions or questions that you want us to cover, let us know in the comments, and then we'll see you back here next Monday at 12 p.m. Pacific to talk all about mobile app development using Corona SDK. Until then, have a great week and happy coding.
Tschüss. Auf Wiedersehen.